Hi, this is Ronald, and today I want to demonstrate cross-site scripting vulnerability and attack techniques. So before we get into it, I just want to show you my setup. So we're doing this on a virtual machine network. So we've got a web server here under a NAT network. We've got our Kali Linux, which we'll use for attacking. And we also have two dummy VMs which will come into play later. We got one running Linux Mint, and we have another running Windows 10. All right, so okay, all right, so I'll bring up Kali Linux and we'll get started. Now, before we get into it, so what is cross-site scripting? So the idea of cross-site scripting is to insert your own script into a website and then use that script to basically attack or steal information from the victim. Generally, this is done through JavaScript, which we will see later. Okay, so first thing we'll do is we'll bring up the target website. So we're going to be using extremely vulnerable web application. So this is basically a tool we can use to test out these attack techniques. There's two tabs we'll be working with mostly. The cross-site scripting reflected, we'll go over that briefly, and the cross-site scripting stored. So yeah, XVWA, it makes things pretty simple for us. We can click that and we can definitely know that this is going to be cross-site scripting. Sorry, that this is vulnerable to cross-site scripting. So which is there to help us learn. So we'll just go over the reflected one. So it's saying here that we can. So what we can actually do is we can actually put our own HTML code here. So so this is just some very basic heading HTML tags, and we'll click submit, and we'll see, yeah, it's reflecting in that. You can even do in bold. So what this is showing us is that this website is processing HTML code that we enter and reflecting it on the website itself. So that by itself isn't too dangerous. But if we can actually run JavaScript, that can be an issue. So we'll say script. This is so yeah, the best way to see if it's vulnerable is to just do a very simple JavaScript. So the alert is pretty simple and it's pretty much instantaneous. So, all right, so if we click submit, oh, there we go. So we've got a alert which says the text we specified, which is hello. So yeah, this confirms that this section of the website is vulnerable, as we can pull off we can put our own JavaScript. Now, I suppose we can definitely use this page to run our own JavaScript, and that JavaScript could contain malicious script which could attack the website or try to extract data. But I think this one is a little more interesting, the stored XSS. All right, so what's interesting is this area, the cross-site scripting stored. So this page lets us put comments. So we can say, for example, John, and the HTML tags should work here as well. Okay, and if we submit that, so we can see that our comment containing the HTML tags is reflected whenever someone else opens up the website. So let's actually see if the script works. So we'll put Jane here, and we'll put script. We'll do alert again. And we'll also put some plain text here as well. Okay, I will submit that. Yeah. Okay. So we can see that when the page loads, it's actually loading our script, and the script is giving the alert for XSS for the win to show up here. And if we actually have a look at the comment, the only thing we see here is "Hello, John." So the comment looks pretty innocuous, but it's actually hiding that alert script. And anytime anyone enters the site, it will be triggered. So if I go here again, it says XSS for the win. So this is yeah. So with the alert, it's fairly obvious whenever it is triggered. But if we have something a little more stealthy, then people won't know that it's being triggered, and they'll just see this innocent-looking comment. I'll demonstrate with the Linux Mint. So if we open up the browser here, so keep in mind this is another machine. So this could be a user across the world. Say click XSS stored. And there we go. XSS for the win is showing up here, and the comment section is loading. And they are not aware that Jane's comment is triggering that. So that's kind of the basic idea on how to do this manually. Now we can certainly write our own JavaScript and put this in the comment section, and we can do all sorts of things. But again, this does require working manually, and it does require us to have a strong knowledge of JavaScript. So so the best way to go is sort of to use an automated tool. And all right, I've installed an automated tool for this process. It's the browser exploitation framework. Exploitation. So it's this one. All right. So if you want to install it, you should. I believe yeah. So sudo apt get install. So if you run this command, you should be able to install it. I already have it installed, so I will just run it. So that's beef dash XSS. And we can see that this beef service is running. Okay. And it should open up. Okay, yeah, it tried to open it up, but there was just a small error. Doesn't matter. We can copy this web UI link. We can then paste this here, and it prompts us to log in. Um, now I've already set a password for this, but the default is beef. The first time you run it, it may ask for a password. Anyways, so this is our beef command. So our beef sort of command server is running on this, and this is the UI we can use to manage things. So as you can see here, there's online browsers and offline browsers. So these are some machines I previously hooked when I was testing it out. It shows them as offline, and we can actually gather some information about them. It's stored the information we've gathered earlier. But in order to hook them, you can use this hook script. So if we copy this, we put it in a text editor. Now you do have to put in the IP address of your machine. So yeah, we can just confirm that with ifconfig. All right, so we'll copy that. So this is all you need to put in the cross-site scripting vulnerable field to get Beef working. And as we'll see in a moment, Beef is a extremely powerful tool. So we'll go back to our comment section, and we'll put another person, and we'll say hello Jane, and this is our beef hook. And yeah, as we can see, the alert from Jane is triggering. And okay, yeah, so we can see there's an innocent looking comment here. But if we go back to our beef control panel, we can actually see that we've actually hooked this browser. But hooking your own browser, that's not the funnest. So let's hook another machine's browser just for fun. So we'll load this. XSS for the win loads. Don's comment shows up here. And we'll also do it on the Windows too. 0.2.6 WA. XSS for the win. Yeah, and there we go. Don's comment showing, Jane's comment is showing. Now let's actually go back to our Kali Linux. Go to our beef control panel. We can see we've hooked two more. So we've got a Windows machine, so that must be our Windows 10. We've got another Linux machine, that must be our Linux Mint. So just by hooking, it's already captured quite a bit of information. So we can actually see here the browser name reported. That's Firefox. It's running Linux. We can see the plugins we're using. We've captured the cookie. Let's see what else we got here. We can see it's an X64 CPU, 2 cores, GPU, and we can see that the screen size reported is 600 by 800. Again, Linux. And let's have a look at what it's captured for our Windows machine. So we can so we can see that it's actually running Microsoft Edge, Windows 32. Again, we've captured the cookie, which should be different. Yes, so it's a different cookie for the different cookie between each machine, between each machine, and we can see the screen size. We can see that's running Windows. So it's already captured quite a bit of information we can use to identify the device. Now, yeah, so we can also see that there's this log section. So we're actually logging the mouse, we're logging their clicks, and okay, yeah, we're logging their mouse, we're logging their clicks. And if we go, let's just test this out. We'll go to the Windows machine. We'll say, we'll actually see if it's keylogged. I'm not 100% sure if that should do it. Okay. No, it doesn't appear to have done that. All right. Anyways, so all right, this is where things start to get interesting. We have this commands page. So if we click here, we can actually run. We can sort of run these attacks now. So for example, we can. So let's get something a little interesting. So let's say browser fingerprint, for example. Let's execute this on the Windows machine, on our Windows victim, and we've got this browser fingerprint. So this is some information we can potentially use. And if we go on the Windows machine, they are none the wiser. They're still on this page. They have no idea that we are essentially spying on them. And we can also get the cookie this way as well. So yeah, we can. All right, so we can. So if we run that, we can see that the result has got us the cookie. We can also get the HTML of the page. So if they've written something here, no, it doesn't look like. Okay. And we can, all right. So those are, and if you go down here, you can actually see there's alert. We can actually send an alert. So we can actually do something a little more overt. So we can say, hello Windows, execute. And if we jump back to the Windows machine, it will say, hello Windows. So again, that will sort of alert the victim, but that's something you can use more with social engineering. So let's say we got this one here. So we can say, uh, let's say, timeout. Please re-enter your password, and we'll execute that. We'll jump back to our Windows. Timeout. Please re-enter your password. Okay. And let's say we fall for it. We say my secret password. Okay. Prompt goes away. And if we go back to our command server, there we go. We've got we've got what they've typed in. So if they fell for it, we've got their password. And we even got this one. We can do a rickroll. Okay, let's see how this works. So the video that they have linked to doesn't appear to be working, but that would rickroll them. If you notice here that these things have color codes, so some are green, orange, and red. If we go here, we can kind of see there's a key here. So the green ones, these work against the target and should be invisible to the user. They work, but they may be visible, and it's saying that this command will not work. So if we try that, we'll see if this works. According to Beef, it shouldn't. Yeah, see, so it says fail unsupported browser. So yeah, there's these browser ones. This is just sort of the tip of the iceberg. There's a lot of stuff here. So we got there's a lot of exploits we can run. These are just the ones that come with Beef. You can of course add to these ones. Detect miscellaneous. Can create, read, send. There's some WordPress ones that work here. Right. I think some of the more interesting ones are actually come from here. So what we can do is that we can actually do some social engineering. So all right, we can. So this will actually display a fake Adobe Flash Player pop-up for the user. So as we can actually customize the payload. We can and then when they click the payload, they'll actually get this link. They'll actually go to this URL, which can be a malicious site that we've created. So all right, let's give this one a try. We go to our Windows test. The Windows one appears to be a little stuck. All right, no worries. Let's hop to our Linux Mint one. Do it on that one. Okay. Commands, social engineering, execute. Go to Linux Mint. Right. As we can see, this one, the Linux Mint machine appears to be having trouble getting that resource from getting the PNG resource from our attack server. So that one isn't working out so good. This one I have tested, it does work. So, all right. So what this one will do is actually it'll put a fake Gmail login. So we'll execute that. And yeah, we've redirected the user to this fake Gmail page. Now, yeah, so I guess the idea here is to trick the user to think, oh, their Google account has timed out and they need to log in again. The UI, the interface is a little bit old. Doesn't really reflect the current login, but again, this stuff can all be customized. So I was about to put my own login there. All right, so we can let's say the user falls for it. Say example at gmail.com. Password is word. We'll sign in, and all right. So this one, and what happens is they get redirected to a real Google account, and the chances are they've already signed in, so it'll actually just take them back to their Gmail, and they probably won't notice anything. Otherwise, they might see this and think, oh, there must be some bug, and they'll sign in and they'll actually get their real Gmail. But what we've done is we've captured their login details. So example at gmail.com, my secret super password. And yeah, we have if they type those details correctly, we have their account details. Okay, so I think we'll just wrap up the demonstration here. So yeah, as we can see, if we so as we can see just from this comment section, we literally put one line of JavaScript code which links to this powerful beef framework, and we're able to pull off all these attacks against the victim. So it's a pretty big vulnerability, and it's a pretty powerful attack we can pull off against them. Before we wrap up the video, I just wanted to go over some ways we can prevent cross-site scripting attacks. So I'm just going to be using OWASP as a reference. So these guys, they basically specialize in in researching web vulnerabilities. So the first thing they recommend is using a framework. So if you use a modern framework, this framework will basically already have defenses for cross-site scripting built in. And the ways you add articles and add pages, for example, those will sort of automatically have those defenses. So you essentially, you sort of don't, you sort of, you do need to worry about them, but you don't need to worry about them as much. Because as with any piece of software, there's still vulnerabilities. You still have to keep that up to date. So yeah, you still have to worry about cross-site scripting, but the framework can take care of a lot of that for you. Another technique they recommend is output encoding. So the idea here is to convert the HTML and JavaScript code into plain text, and you essentially neutralize the cross-site scripting as it's displayed as plain text instead of it being interpreted as code. So many frameworks do that automatically. So I guess the sort of the way that works is it will sort of it'll take it'll take characters used in scripting such as this greater than or less than symbol, and it will convert that into characters like this, which are interpreted as plain text. That's sort of just the basic idea of how that works. So in cases where that is not a where output encoding isn't going to be fully effective, we can also do HTML sanitization. So what HTML sanitization do? It's sort of an input validation kind of thing. So the idea is that it will strip dangerous elements from HTML, returning a safe HTML string of code. So, for example, it might strip away things like script or alert, which are things that are not expected in a HTML editor. And I guess the last method I want to go over is a content security policy. So the idea behind this is it's a fallback strategy to minimize the impact if a XSS injection attack is successful and gets past those defenses. So content security policy essentially creates a whitelist of allowed scripts and sources, and any content that does not match the whitelist is blocked. For example, we could essentially block. We could put on this page some code that will block any script that refers to a remote site, which is yeah. So that is one method that would neutralize this attack if it got past those defenses. So you can basically set up all sorts of rules based on what the content of that page is. Okay, so yeah, that basically wraps things up. So yeah, we demonstrated how to pull off some manual cross-site scripting. We showed the power of these automated tools, and we went over some methods to to mitigate or reduce cross-site scripting vulnerability. I hope you found that useful. If you have any thoughts or questions, feel free to leave them in the comments. And yeah, and if you want more cybersecurity videos, please subscribe for more. Have a good day. Bye.